at HCS. I'm joined on the call today with Johnny Kiley, who is the HCS Technical Director. And we've also got John White, who is the Head of Cybersecurity Solutions here at HCS. I hope that everyone got their coffee mugs in the post. If you haven't, please reach out to us after the webinar. We'll be happy to send you another one. Just, some ground rules for today. The chat box is moderated, so please feel free to send in any questions that you have as we run through the presentation. There is some time scheduled at the end for a bit of a Q&A. So if you do have any questions, please send them in. It won't appear to everyone. It will just appear to our moderator. So I'm going to turn off my camera just for the presentation piece because we had some issues with my broadband this morning because I'm still working from home.
Yeah, I think we're all going to turn off our cameras just sort of save the bandwidth and not have the flickering, yeah.
Yeah. Okay, so the agenda today is going to focus on building a zero trust architecture with two of the industry's leading vendors in Microsoft and Fortinet. Zero trust is absolutely everywhere right now, and there's a multitude of vendors out there saying that they can cover many different aspects of zero trust. So, it can be a bit confusing. We want to use this opportunity to show you exactly what a zero trust deployment will look like from Fortinet and Microsoft, what that looks like. You can, of course, plug in your own solutions into, when we go through a strategy slide in a minute, you might have some solutions already that are plugged into them spaces. That's absolutely fine. But obviously, there is an advantage to consolidating vendors to have as few as possible. This isn't mutually exclusive, but the way we are looking at this is Microsoft is going to be surrounding your identity security, and Fortinet is for your device security. And then what you have is best of breed technology to implement zero trust. Then we'll finish up with how to implement zero trust in your organization and what that will look like. So to start, what is zero trust? It is security to anywhere and everywhere. That is, you work from anywhere on any device. The zero trust model moves security away from implied trust that is based on network location. Instead, it focuses on evaluating trust on a per transaction basis. With zero trust, network location or IP address no longer conveys an implication of trust like it did in the past. The zero trust model stipulates that trust should be explicitly derived from a mix of identity and context-based aspects. Zero trust means no one should automatically be trusted once verified. Only limited access should be given and then re-verify. So there's that continuous check happening to make sure that you are who you say you are and your device has been authorized to access the information that you're accessing. Zero trust access focuses on understanding who and what is accessing the network. Never trust, always verify, which means that devices should not be trusted by default, even if they are connected to a managed corporate network, such as a corporate LAN, and even if they were previously verified. There's that continuous check that needs to take place. So, why zero trust? There are a number of advantages. Here we are in 2022 to why zero trust is a great strategy to implement in your organization. Everyone these days has, digital transformation of some sort happening. You've got, an increase in attack surface across the cloud and a hybrid workforce. The number of identities and endpoints that you need to trust has increased tenfold in the last number of years. You also need to have a flexible security strategy. If there's anything the last couple of years has told us, it's that, with a change in the environment, you might need to change your security strategy pretty quickly. Zero trust allows you to do that. It just allows you to be a little bit more prepared in case of something out of your control happens. Cyber attacks are becoming more sophisticated than ever before. We've got polymorphic malware, you've got state-sponsored attacks, you've got dark web tools that I can go on and purchase right now and attack, you know, anybody I choose just from the comfort of my own home. There's a skills shortage. You cannot fill cybersecurity roles or even train IT roles to train in cybersecurity skills. You need to be able to do more with the products that you have. And you know, the last number of years, we've seen a massive increase in the number of cyber attacks. And one of the reasons is, you know, for cyber criminals, the risk is worth the reward. For very little effort, they can ransomware a machine or an organization and get paid, right? So I was reading a bunch of articles in the last couple of weeks saying that organized crime have moved into ransomware in a big way, and they're using ransomware to fund their other activities. So that's why we're seeing a massive increase in the amount of ransomware attacks that are prevalent today. And you know, 34% of businesses around the globe are affected by insider threats yearly. And interestingly enough, over the last 2 years, with people working from home, whether by accident or whether it was on purpose, then that number over the last 2 years, the number of insider threats has increased by 47%, which is quite alarming. So, you know, what we're going to look at here is the HCS zero trust strategy. Okay, and we're going to talk about a number of different scenarios and how this zero trust strategy is going to stop the bad actors or the insider threats from happening. But to start, you've got what we would call like a good actor, being me up on the top left, and then a bad threat actor underneath me. You've got, you know, two at the moment to our organization. These two are unknown. What they will do now is go through what we would call our Trust Gate 1. Johnny, do you want to talk a little bit about this gate?
Yeah, thanks, Paul. So, as Paul was saying, we're assuming that we're taking you through the journey that users will go through and that the attackers will go through on their way, basically from outside the network or potentially inside the network, but to the journey to the data and the applications that they use. So we start with unknown users, unknown devices, be they laptops, desktops, or mobiles. And we're going to start talking about identity. And Microsoft uses Azure Active Directory as their identity platform. It gives, obviously, people mostly know it for signing into your things like your Exchange Online, your Outlook, your SharePoint, your Teams, your OneDrive. But it's also a single sign-on solution that can be used to sign on to millions of applications, from Salesforce to Autodesk to Sage. And that one set of keys that a user gets when they join the organization, one of the first things IT does is they create a user account for them. It's a username and password, and if you can give them the fewer set of keys that you can give them, the better. Sometimes when people join an organization, they get one username and password to sign into their machine, another one to sign into the payroll, another one to sign into the CRM, another one to sign into the marketing application, and so on and so forth, to bring that down to one identity, one set of keys, and then to monitor the usage of those keys and protect those keys. So in the tool set, we have multi-factor authentication. So a user not only needs their username and password, but they also need a third device. Generally speaking, you're talking about a smartphone, and whether that's a regenerating 6-digit code or the Microsoft Authenticator app. So when they sign in, a notification pops up on their phone and they hit approve. Yes, I'm trying to sign in now, and on I go. You can increase your security even further then with tools like conditional access, which gives you the IT and the company the ability to restrict access even further. So we can, rather than just giving everyone access to all of the applications in Microsoft or the marketing applications or the CRM applications, you can restrict down what applications, what users and groups are allowed to access. You can restrict what countries they're coming in from. So if you have offices in Ireland and the UK, but no offices outside of there and no remote users, you can restrict those groups to signing in only from those countries and block all other logon attempts. You can go down as far as restricting the times of day that people log in at. So, you know, from 7 o'clock in the morning till 7 o'clock in the evening, and people who are accessing systems outside of those hours, you can have it granular. So you might have salespeople who will work till late at night, but your general operators might finish at 5, 6 o'clock in the day. You can restrict session lengths and stuff like this, so that someone can't leave a machine on and signed into their account with the access open, and someone else can sit down, or someone takes control of that machine and uses that identity to do malicious or dangerous things. To layer it on even further, then there's identity protection, which basically uses Microsoft's massive information set to monitor and protect the identity. So Microsoft can see what anonymous IP addresses are being used by VPNs and malicious IP addresses. They can detect logins coming from those IP addresses and flag them as risky. They can detect logins happening that are a user logging in from Dublin at 9 o'clock in the morning, and then another login happening on that same account from New York 20 minutes later. These are two impossible activities, so they can flag that as risk and block that sign in, or mark that user to have to change their password and enforce MFA. They'll obviously see things like malware listed IP addresses and so on and so forth. Just because of the size of their network, they just have visibility on all of these things to really lock down and protect the identity and secure it. Then the Microsoft solution for protecting devices is Intune, or Endpoint Device Manager, where you can implement configuration and protection policies that allow you to secure those devices and identify that they are secure. So you can deploy things like certs, VPNs, Wi-Fi, install applications and policies on the machine so that they're all a standard set for each role within the organization. You can enforce things like pins and encryption, so that people, you know, sales guys who have their smartphone connected to your network and access to your email and access to your SharePoint and your marketing material or your sales material, that there's a minimum standard of security, that the device is protected with a pin, that the device is encrypted so that it can't be picked up at easily, and that information, you know, exfiltrated from the organization. You can create policies to protect your organization from a kind of the malware element of those things, with blocking jailbroken phones. You can block copy, cut, and paste between the applications. So a user who has access to sensitive information can't copy that data and just paste it into a Notes app on the phone or the tablet, or share it to their Gmail or their Apple Mail, and all of these things layer onto a compliance policy. So you can then say, once all of these conditions have been met, this device is marked as compliant. I will allow a user with a compliant and trustworthy device to connect to my organization. Or you can, you know, if you don't want to go down that very restrictive route, you might just have it that report to me the non-compliant devices or the warning devices, so that I can then contact the users and say, you need to do this to get your machine active. You need to make sure that, you know, update the version of the operating system and update your iPhone or whatever else. We also have the ability to remote wipe and selectively wipe devices. So if people leave the organization, or if people lose their phones, we can wipe the Outlook data and the SharePoint data and the Teams data off an iPhone, but leave everything else. So if an employee leaves, you know what I mean, it's relatively non-destructive for them. But if someone says to you, I lost my phone on the train, we can then remotely wipe that device completely, destroying all the data on it. The same with laptops, tablets. Then from a protection of the operating system and the endpoint point of view, we use FortiClient and Fortinet, FortiEDR, which is a modern antivirus. The traditional antiviruses were stuck trying to use virus signatures to identify what is malware. And obviously the malicious actors then know what's being detected and can change it. So there's this continuous cat and mouse game of one getting in front of the others to getting malware delivered out to people, getting it onto the machines. The modern antivirus not only monitor based on the signatures of the files and the viruses, but also what those things are trying to do, the behavior of the devices or the behavior of the software. So ransomware typically will try and reach out to a command and control center. It will try and encrypt files on a device. It will remove the backups. It will remove the shadow copies. So we can, the software has the ability to know, it doesn't know what this piece of software is, but it knows what it's doing is dodgy, and it shuts down that executable and can log that event for further tracking and alerting further down the road. Blocking machines from connecting to the network is stopping the spread of these infections from one machine to another and tracing it down through. So once we're happy that all of these things are met, once we're happy that the user that's signing in is securely signed in from the right location with the right compliance on their device, and that the machine that they're connecting from is protected with our modern antivirus, and we know that there's nothing suspicious happening, we're then happy to pass them on to the next gate and mark them as identified and protected where further actions are taken.
Okay, thanks, Johnny. Just looking at one or two scenarios in this first gate, right? If you look at, for example, this guy underneath, down below on the screen, is a bad threat actor attempting to gain access. How is Trustgate 1 going to stop that from happening?
Yeah, so those type of actors coming in are generally coming in one of two ways. They're either coming in from their own machine, in which case they're maybe trying to access through your firewalls or through your directly to your cloud services. So if you're using your Azure AD single sign-on and your Azure Active Directory, we're seeing those connection attempts happening. We're seeing if he's stolen your credentials somehow or other, you'll see that log coming in. The conditional access would block it if it's coming from a spoofed country. The fact that he doesn't have your MFA token would block it. The fact that he's not coming from a non-compliant device would block it. Another way they'll often try and get in is they'll try and get you to click on an email link or a compromise some web page or something like that to get some piece of software onto your machine. And that's where the likes of EDR come in, monitoring that behavior of that piece of software that you don't even know is there and stopping it from doing whatever it is that they want it to do.
Okay, so we're protected by the traditional way of a bad actor getting in, but also even if they are piggybacking on, let's say my machine here is compromised, we're picking that up at this gate as well.
Yeah, exactly. So after you sign in and you're after you're on the network, if you at that stage download something and your machine starts misbehaving, doing something that we wouldn't expect it to do, that's where the EDR comes in and shuts that down.
Okay, great stuff. So that means that the bad threat actor hasn't gained access, and we're moving on to the next gate, which is authorizing. So John, do you want to talk a little bit about Trustgate 2 and what's happening here?
Yep, exactly. Thank you very much, Paul. Thanks, Johnny. Basically, this is broken down into three areas on our system. The first one is the Azure AD, which is the Azure part of it, the role-based access control. What this allows us to do is it allows us to find roles for users and groups, and we can define what they can have access within our Azure and Microsoft 365 tenancy. It allows us to define rules to say what resources, and part of those resources can be virtual machines, storage, applications running within our environment. If somebody tries to step outside these rules, this will flag alerts on the Microsoft systems, and we can then look into it and we can see what and why somebody was going where they shouldn't go. It can also configure it to be blocked and alert administrators for those attempts. This is ongoing, and it's again every time somebody tries to access parts of the resources, it will have to be validated, and that validation then will say block the user from that accessing the resources that are not allowed to. The Fortinet Ssl Vpn allows us to have a secure remote connection from our endpoint devices to our resources via a FortiGate firewall. FortiGate firewalls don't only have to be on-premise, they can also be up in cloud services such as Azure or AWS. therefore protecting the assets behind those firewalls as well. So also the SSL VPN has multi-factor authentication. So it's not only a username and a password combination, it's also a secondary device, which again, the same as the Azure AD, can be your phone, it can be a code to your phone. That will give you your say. So even if a bad actor gets your username and password for your VPN, it'll be blocked by the secondary device because they won't have access to that device. The other thing we can do here as well, we can do geo blocking. So if a user normally only operates within Ireland, we can tie down the SSL VPN to say that only access is allowed from Ireland. So this gives us access into our network resources, and we can also set up rules to say, this group of users can only access this server remotely, or they can only access these servers or this server and that printer remotely. So again, we can tie down the actual, what they have access through the SSL VPN. The next step up from that is the Fortinet and the ZTNA. The ZTNA is the Zero Trust Network Access. What FortiGate have done here is they allow us to set up a set of rules. And those set of rules will say that this endpoint device with this user on it is only allowed to access these resources. And we can even tie that down to ports on the actual device. So for instance, RDP would be 3389, and then we can only RDP onto that box. The main difference between the SSL VPN and the Zero Trust Network Access is that the Zero Trust Network Access is continuously monitoring the activities of that machine. If that machine falls out of compliance, it will be immediately, by default, blocked from the network. But again, we can set up rules to have it isolated in its own separate VLAN, and then we can do remediation on it in that separate VLAN. So that the Fortinet allows us then to create rules. Once a device is connected on our network, we're able to create quite complex rules to say, if it's this MAC address, with this user logged on, running this application, then it can go into this VLAN and can access these resources. And again, this is ongoing. So if something changes on that machine, it'll change the NAC rules so that the access that it's getting is changed. Okay, thank you. Paul.
Okay, thanks, John. Yeah, so, then those, the correct people there have been authorized. And in scenario 2, or 3, let's say, we've got another internal user here is Kathy. And Kathy is using one of our home machines. I think it's an old Apple Macintosh, right? So it's a relatively old machine that she's using to try and gain access to company resources. Now, it's legitimate access, but how is our Zero Trust strategy as a whole in using Trustgate 1 and 2 going to pick up and block that potentially malicious machine from gaining access from what looks like a legitimate access?
Yeah, well, basically what will happen here, Paul, is, the username and password will be validated, so that'll be okay. But what will happen is the Intune compliance, the Forti EDR, and also the SSL VPN and the ZTNA, the machine will be outside the compliance because it'll be a non-supported operating system. So it'll block it from there. So even though she has the correct username, password, and multi-factor authentication device, because the machine doesn't come into our compliancy range, it'll actually be blocked from accessing, both at the identity and protecting gate and at the authorizing gate.
Okay, brilliant. Thanks, John. So we say that machine has not gained access, and now we're moving on to the third trust gate, which is monitoring. So Johnny, do you want to speak a little bit about this?
Yeah. So the first gates and second gates are all about gaining access, identifying the person, and then giving them access only to what they need. The third gate is really about making sure that these things are behaving in the manner that we expect them to behave in. One of the, I suppose it's a layer of security that we can apply in Azure Information Protection that allows us to classify and protect data based on the labels and the classifications that we choose for it. We predefine these labels, so we may have things for sales and or directors that are sensitive or secret or whatever, and those labels then define who is allowed to access that data. That protection sits inside in the data. So it doesn't matter if someone if you have financial sensitive information or IP information that is protected in this way, if that was accidentally emailed or left on a storage device, the protection sits with the data. So someone trying to access it, is required to sign in. Also, all of their activities on that protected data are monitored and reported on. So if someone has access to sensitive information and they're allowed to open it, that's fine. All of that activity, when they opened it, where they opened it, it's all monitored. If they're allowed to share it and change the permissions, all of that activity is monitored. So it's really about that behavior of kind of identifying what we expect to happen and making sure that it's happening within those predefined boundaries. On the networking side of things, then, when you're talking about everything from your 40 switches, your 40 gates, your access points, your endpoint detection, your FortiMail, all of the Fortinet suite of security products all come together and communicate through the security fabric. Traditionally, when we have Cisco switches and Palo Alto firewalls and Aruba access points, and we have, McAfee antivirus on the machine, when something goes wrong, we're logging into 5 or 6 different devices, tracking through logs, trying to find out exactly what happened, following the breadcrumb trail back to the endpoint device, logging into the machine and looking through the logs on that machine. The zero trust strategy and the unified centrally managed solution pulls all of that stuff into a single place where all of those logs are collated, and we can see a high level centralized picture. We can see what users are accessing what websites. We can see what applications they're using, what social media you're using. We can see what bandwidth is being consumed from what endpoints and between what networks, and we can detect outages and respond to things like that. We layer that on then again with FortiXDR, which will take in not just stuff from the security fabric, but also stuff from identity and access management solutions, cloud solutions, which will give us the ability to take all of this information and layer AI investigation on top of it to investigate those issues and pull out a lot of the false positives and the noise that happens when you do have all of this logging kind of feeding into a single place. And John will talk about it more in a minute, but we can do policy-based responses and playbooks where we basically define that if X happens, do Y. So if an endpoint on a site is compromised, disconnect it from the network. If 3 or 4 endpoints on a site start getting compromised on a network, shut down access from that entire site, bring down that site-to-site VPN. But what we're talking about here really at the monitoring gate is making sure that we understand the behavior that we expect to see and that we have ways of identifying when unexpected behavior is happening.
Thanks, Johnny. So then when we wrap a cloud around it and we include Microsoft 365 Security Center, a FortiCloud SOC as a service, John, do you want to talk a little bit about that?
Yeah, basically the 2 items then that glue all this together. So we're talking about all the monitoring, which will take in everything from the previous 2 gates, the authorizing, the identifying and protecting, and send all the data gathered here up to the 2 services. The Microsoft 365 Security Center is basically, it's a central place where you can manage all of your security from Defender and Office 365 security and compliance. It combines protection, detection, investigation, and response to email, collaboration, identity, and device threats in a central portal. It also enables people to manage centrally your 365 services, Office 365, Windows 10, enterprise mobility, and some parts of the Azure infrastructure as well. So it allows us to run reports to see where our compliancy level is and what steps we have to do to improve our security rating within the Microsoft 365 Security Center. The other part of this overall view into everything is the FortiCloud SOC as a service. The SOC as a service is basically a 24/7, 365-day-a-year service. All your Fortinet fabric. The Fortinet fabric is basically everything. It's your Forti client, it's your Forti switches, It's your 40 access points, your 40 gate firewalls, your 40 EDR, even your XDR can report back into the SOC. And what will happen is the SOC then will collate all this information, and using a combination of AI and physical humans in front of it, give back reports to users, and then detect compromised hosts, malware, unauthorized access, or command and control and botnet incidents. Everything is being monitored here. So we're looking for, from the EDR, we're looking for indicators of compromise or suspicious activities, or some application that's trying to give itself a privileged access to something on our operating system. It then can respond. So basically the SOC will build up what they call playbooks, which will be, if a machine in this group gets a botnet on it, this is what we want to do. So we want to escalate this into our own support team, and that support team can block the device, or we can have an event within the playbook that the Fortinet fabric will have blocked the device. So then we have to report it to the in-house IT team, and they know what's to happen, and they'll also get an email with steps to remediate against the event. Or if it's a more serious event, we can have a separate playbook, and that playbook will actually involve picking up a phone from one of the SOC engineers to an IT support contact and talking them through what's happening and how to remediate it. And then they will help within the remediation of the event. And not only all those response and the communication and the escalation path, they will also then afterwards investigate exactly what happened with the IT team. So there can be a correlation of the events that happened, and then after that, then we can look at why it happened, where it happened, and then block those gaps within our security system. So the key thing here is that these two sit on top of everything else underneath, and this is where the real power of your zero trust is coming in, and that it's ongoing 24/7 monitoring of all your IT infrastructure. So any non-compliant or dodgy, as Johnny said earlier, dodgy activity will immediately be flagged, and we then have an opportunity to not only block it within minutes, but then to react to it and have a playbook designed about what we have to do and how we have to do it. All right, Paul?
Yeah, thanks, John. So I've got two scenarios left. Johnny, if you want to take the first one, and then John, I'll ask you to come in again for the second one. But Johnny, the first one is, God forbid, Kathy decides to leave HCS in the morning, and before she leaves, she tries to take some data with her and access. You know, she's a legitimate user. She's accessing data that she's got access to. You know, she hands in her notice she's leaving tomorrow to go to a competitor. You know, how is this strategy going to help prevent that from happening?
Yeah, two products really kind of facilitate here, because what we're talking about is she has legitimate access to the data. So information protection, you know, allows us to obviously limit the access she has and report and respond on the activity. So if a user, you know, would actively download, you know, 30 or 40 kind of files on a day, or open, and all of a sudden they're downloading 5 or 6 gig in an hour at 8 o'clock in the evening, we can put policies around and react to that and block that access. We can also alert on it. Also, you know, may very well have information stored on iPads and laptops, and Intune gives us the ability to selectively wipe that data, even data that may not be classified or protected, but is still inside in those applications, like access to all of her previous emails and some such. So Intune gives us the ability to pull that information out, you know, without wiping the device and causing a political nightmare. We can remove access to the Teams chats, to the Outlook information, to the SharePoint libraries, and the OneDrive documentation. That's how we protect against that.
Thanks, Johnny. Yeah, pretty comprehensive. John, the last scenario that we're going to go through, and it's a dreaded zero-day attack. Right? I'm sure, you know, over the last few months we've all seen a few, one or two of these coming through. So, you know, how is you know, this strategy going to help protect against a zero-day attack?
All right, Paul, thanks. Yeah, basically what will happen here, Kathy or yourself, or after clicking on something or downloading something, and or even drive by a website and you're after getting infected, basically what will happen here is that the FortiEDR will detect some suspicious activity, be it files being encrypted, trying to copy files into certain locations, trying to change the executable code on certain files, or activity that user normally doesn't do on their system. That will trigger an event into the XDR, and it'll say that activity shouldn't be happening, and it'll immediately lock out the machine. But it'll also report that into your FortiGate, which will then block the machine from any network protected by any FortiGate within your fabric and any switch or access point within your fabric. And then the FortiCloud SOC as a service will have that event reported to it and flagged, and then they will then either by email or telephone, based on the playbook, will contact the in-house IT team and say, this has been detected, this is what you need to fix it. So the first thing that will happen is, as soon as that bad actor starts to infect the machine or run its piece of code on the machine, that's when immediately the Fortinet fabric will kick in and isolate that machine off of any of our resources on our live network, which is key. And that event then will be looked at by senior FortiGuard and analysts, human analysts, to actually tell us what's going on and what to do to fix it. So it's very comprehensive in how it's blocked off, Paul.
Yeah, absolutely. And it sounds like, you know, speed being key in a zero-day attack. And
exactly.
What we're doing with the fabric and the SOC as a service is picking up on this suspicious activity very quickly and quarantining that machine, so the amount of damage that can be done is limited.
Basically, we're trying to limit the damage to the actual device itself, the host that's infected. That's the primary. And then we can look at remediation, such as cleaning it or wiping it and rebuilding it. There's various, you know.
Okay, thanks, John. So I think, you know, just to summarize, I mean, you know, we've had two unknowns coming in. We've identified and protected the identity and the machine. We've authorized them to say that they have access to our network, and then we're monitoring both the identity and the endpoint. And we've went through a bunch of scenarios where a bad threat actor is attempting to gain access, or again, piggyback on one of an authorized machine. We've acknowledged to bring your own device to work, and how this strategy is going to restrict anything bad from happening there, or dodgy, as the guys would say. We've also looked at the insider threat and how this strategy is able to, again, mitigate that from happening, and a zero-day attack. So now we're moving on to just the last, this is the last slide, yeah. So moving on to how you implement Zero Trust. And we've broken this into a company with less than 150 employees and greater than 150 employees. And there's actually very little difference in both scenarios, right? If you've got less than 150 employees, you're looking at a Microsoft E3 license, FortiGate, FortiClient, FortiXDR, and EDR. Now, if you've got 1,000 users, you know, you're going to be paying more per license. So that's where the additional cost is going to come in. But, you know, for a site with 50 users, you know, it's going to be considerably less, because you're paying for a smaller FortiGate and less unit cost for the FortiClient, XDR, and EDR. FortiCloud SOC as a service is also layered on top of that, and it again depends on the size of your organization on how that cost is derived. If you've got more than 150 employees, we're going to say you need a Microsoft E5 license. Sorry. Again, the same set of products from Fortinet. You got a FortiGate, FortiClient, FortiXDR, and FortiEDR. One additional product that we're going to put in here for companies with greater than 150 employees is a FortiNAC. You want to know very quickly what devices are on your network, plus what devices are even trying to attempt to gain access to your network. With 150 employees, you're typically going to have more devices. and more endpoints trying to gain access. So Fortinet is a great way to really get a really good snapshot of what's happening and what's trying to access your network and what is on your network. And again, FortiCloud SOC is a service built in on the back end, so that if anything does go wrong, you've got the speed of the Fortinet analyst to pick up the phone and give you a call. And incidentally as well, any SOC as a service is going to reduce your insurance costs, your cyber insurance costs. So, this is a great way of even saving money for other expenses. Still, sorry, I said this, the last slide was the last slide. It's actually this one. Us at HCS, just to caveat this, we're a Microsoft Gold partner, and we have been since 2007. And we're also a Fortinet Advanced partner. We're one of only 2 in Ireland. So with these best of breed vendors, you've got best of breed products and best of breed technology in order to implement our HCS zero trust strategy. It's one thing having the products in place, but it's another thing knowing how to install them, how to configure them, and how to set them up in a way that you're going to get the most out of the product. And if you want us to speak to us about how to do that in a safe and secure way, we're more than happy to help. So that's the end of our content and our presentation. So we like to open it up now. Thank you very much for listening, and we'll listen to any questions and answers. Or sorry, we'll listen to any questions and answer them.
Yeah, I'll just run through the questions and you guys can do the answers. We have a couple of questions in. The first one, using Fortinet SOC as a service, is it necessary to own Fortinet switches in order to automatically isolate or lock out a machine?
Hi, basically, no, it's not actually a function of the switches. It's a function of the Forti client running on the end machine. That will report it into the fabric, and then the fabric will lock that machine out. You will then be left with the command channel from the Forti EMS, which manages the Forti clients, to be able to remediate on that machine. So no, you don't need the Forti switches to automatically lock, but you do need Forti client / Forti EDR on the endpoints to lock out the machines.
Thanks for that, John. There's just another couple of quick questions. Do I have to pay extra for single sign-on?
No, the Azure AD single sign-on is part of any of the basic Azure AD plans. So it comes with the Microsoft 365 E3. It even comes with an Exchange E1 license. There's no extra cost for the single sign-on. There is, you can use it for your customers. There's an extra charge for that, but for the one for your employees, no.
Great, thanks, Johnny. And there's just one final question. Do I have to implement all these solutions on day one to get zero trust?
No. So yeah, I'll take that one. So what you can do is, take a snapshot of where you are today, either by doing an IT audit or vulnerability scan. It can give you a good idea of a snapshot of where you are today. And then it will allow you to prioritize what solutions you need to address, or what areas you need to address as soon as possible, and prioritize which solutions you need. And then you can build up your zero trust strategy, by order of priority. So no, the answer is no, you don't need all of these solutions day one. You can build up over time, starting with what your priorities are.
Great, thanks, Paul. That's all the questions in. So over to you.
Yeah, well, listen, thanks very much for joining. We'll have another webinar in a couple of months, so please watch out for the invites. If you didn't get a mug, please feel free to give us a shout and let us know, and we'll be happy to send you out one. And also, if you do have any other questions around our HCS Zero Trust strategy, or have any questions about implementing any of the solutions that we discussed today, give us a shout and we'll be happy to help. Thanks very much.
Thanks, guys.
Thanks very much. Thanks, everybody. Thank you.